Okay. Good evening, students, and welcome to the Bio-Inspired Design Principles and Practice class. This is session 2, where we will be covering Unit 5. Okay, and let us go through the slides one by one. Now, what is in Unit 2? Okay, so Unit 5, content of Unit 5 is what are the existing bio-inspired designs used by engineers? So most of these designs I have been briefing you throughout in the class. And what are the existing bio-inspired designs used by engineers? Then case studies of aesthetic versus functional designs. Aesthetic means which is pleasing to the eye, which looks good, which fits in the place. It is not just looking good, it is fitting in that place. So that is called aesthetic. Aesthetic versus functional designs. Functional designs means designs which are capable of doing a function. It need not be aesthetically pleasing sometimes. So aesthetic means it should fit with the environment, it should cohere, it should be symmetrical with the environment. But functional design means it should have some function from nature. So how it is getting inspired from nature. Then applications in robotics. So some slides will be showing you of the applications in robotics. Bio-inspired computational techniques. Okay, here I will be briefing on some of the algorithms of bio-inspired computational techniques. Then finally, we will end the lecture with concepts of green building and industrial ecology. Industrial ecology is a separate concept, green building is a separate concept. And finally, we have the some activities on bio-inspired design. This we have been doing right from the beginning, we have been doing activities. So when I planned the syllabus, I kept it for the 5th unit, but we have been doing it right from the 1st unit. So let us go into the content. So this is existing bio-inspired design used by engineers. As I told you, this is the car. This car has been designed by keeping in mind this particular bird's, I mean, fish. This fish is called as a box fish. And you can see the structure of the fish. You can see the similarity. The front view of the fish, the front view of the car. This has been used as a reference to do the car. And yeah, annotation. Yes, I can use a mouse pointer. Okay, you can see. Can you see the pointer? Okay. So this is like the box fish how it is made. And hold on. Hello. Yes. Yes. Sorry. Is, I'll switch off the phone. I thought it is some student. Okay. Now the box fish. You can see the structure how it looks. Next, the side view. Okay. So both are there. Why it is not moving? Okay. This is another example. I told it in yesterday's class also. This is the example of the design of the shark fin. So the box car and the shark fin are two similar examples which are used by engineers as bio-inspired design. Now, applications in robotics. If you look at applications in robotics, what are the functional applications? That is very, very important. So in the left side, you can see here a human leg. You can see the human leg, how the muscles and the tendons are structured. Within your leg, this is how the muscles are arranged, the bones, the ligaments, the joints. This is the structure. So similar to that, the bio-inspired design. See, creating an artificial leg is very, very simple and straightforward. You have to just design a structure which can withstand the pressure. But creating a bio-inspired design is completely different, which has to actually mimic the biological leg. So you can see how the tendons or the muscles are recreated between the left side picture, the human leg, and the bio-inspired design. You can see the difference there. So this is how it is designed. And then in the right side, you can see the prototype picture. In the prototype picture, you can see what happens when you are pulling your foot up, down, what kind of levers and pistons, how they actually make it work. So this is very, very important. And these things are used not just for robotics. These are actually used for creating artificial limbs and legs, prosthetic limbs, it is called, for injured people. So The next slide, the next picture that you are seeing is one which I told you yesterday about the design of a blade, how the blade is designed. And this particular picture can help you understand, what are the bio-inspired designs behind the design of a blade. Bottom, you see what I always used to tell you about the elephant proboscis, the elephant trunk. So elephant trunk can be thought of as like as a proboscis. So this proboscis will be extending and it can be used to go and reach out to unknown places. You can use this. You can use it to shift around. You can use it to shift around and look. You put a camera in the front, it can look into crevices. It can look into very complicated areas, and it can enter other terrains. So now, I want you to look at this graph very closely. I have been telling a long time about most of my students now in this particular class are CSE students. So, I have been telling a long time about all of you that there is a lot of techniques for bio-inspired computational technique, but these are the actual names of the algorithms, different algorithms that are in existence today, most common algorithms. There are many algorithms, but most of the common algorithms you can see here. The bio-inspired computational techniques. So here you see the movement is towards meta-heuristics. Okay, so and here you can see the movement is towards hyper-heuristics. But if you look at the graph, in the left side, you can see the complexity of problems. And in the bottom, you can see progress of time. So you can see here from the 1970s, what happened up to 2015. This particular graph is up to 2015. So you can imagine the kind of advancements now. So you can see that in the early 1970s, there was the neural network. It progressed to genetic algorithms, progressed to leaping frog algorithms. Leaping frog means how a frog leaps. Based on that particular angle, leaping frog algorithm was designed. Then ant colony optimization to solve several computer problems. How the ant colony works, that was used for this particular thing. What you want to okay. Not clear, sir. Presentation. Jagadishwaran to everyone. Don't worry, da. Presentation I will give again. Okay, I will send it to you by WhatsApp also today. Okay, don't worry about the presentation. Mm. So this in 2000, probably it is because of the network error. I have to find some way of sharing the file. Is it possible to share the file? New share. Let me try that. Files. Okay, there is the possibility of sharing file. Mm, Dropbox, Google Drive. How many people are coming in the class now? 23 people have come. How much time elapsed in the class? Any idea? There is an option to share file in chats. I don't think so. I'm looking at a way to send you the PPT right now. Okay, I'm trying to share the PPT right now. I'm trying to open Google Drive. Hey, who's that? I'm trying to attach the file in WhatsApp. Document. Oh, share later, sir. You only complained, no, that you could not see the presentation. It's better to see the presentation for you. Wait. Mm, where is it? Okay, it's here. PDF. Open. Okay. I have pressed the share button. It should be coming up in your screen. Okay. Okay, I have done it in WhatsApp. Huh? So we will go back to the presentation. I'm going to stop seeing the chat box. It is distracting me. Okay, so let me just continue with the class. 25 participants are now there in the class now. Yeah. Okay. I'm still in the sixth slide. I was on the sixth slide. Let me continue with it. So throughout the 1970s and up to 2015, you can see various algorithms listed there. So that is the artificial plant optimization, flower pollination algorithm, bat algorithm, cuckoo search algorithm, firefly algorithm, artificial bee colony algorithm. So many algorithms are there. Basically, they are moving from meta-heuristic problems towards hyper-heuristical problems. And the objective is that you move towards multi-level, multi-objective problems with solutions in a continuous domain. So that is the issue here. So in order to solve, real-world problems that human beings face, nature is being inspired to create algorithms. How nature solves these problems using swarm intelligence or using collective intelligence, that particular aspect is taken and fed into algorithms, and that algorithm in turn powers the programs and software models are designed. Okay, we're going to the next slide. Yes. So bio-inspired algorithms, you can classify them like this: evolutionary models. Evolutionary models means one model becoming better than the other. So these are different kinds of evolutionary models. Swarm-based models. Swarm-based models means groups of fishes or group of bees or group of animals, how they are behaving collectively or individually in a swarm. How they're behaving. Based on that, they create algorithms. So bio-inspired algorithms are also swarm-based. Swarm-based is again of two types: natural river system, human immune system. They can be based, or they can be based on convergent social phenomenon. So some examples are producer, scourer, or bird flocking, behave, and social behavior of bees, and frog jumping, simple frogs jumping in groups or individually. And bioinspired algorithms is also based on ecological models. Ecological models means biogeography, weed colony, symbiosis. So different models are used from biology in order to design algorithms. So the name is actually there, basically classified. Okay. Right. Now we are coming to the end of the session almost, where I have to introduce you to a new concept. It is called green building. Bio-inspired design also means that you have to design while keeping in close contact or in close consideration of the ecosystem or the environment at large. So environmental concerns are at the cusp, very, very important. And nowadays in the newspapers or anywhere else, you might have seen that there are lots of advertisements where the buildings are certified green, where energy saving is there, and they have something called as the lead rating. So this is kind of lead rating, and this is mainly targeted towards, the concept of sustainability. Sustainability means providing something for the present generation without compromising on the ability to provide the same resource to future generations. So that is the meaning of sustainability. There are different types of sustainability: social sustainability, environmental sustainability, industrial sustainability. So here it is environmental sustainability mostly. The place where you build the building, how you are going to build the building, what powers the building, whether all of these things are sustainable in the long run. All of these things are coming in concepts of the green building. So any building which is built by respecting or keeping in mind these principles will come under the concept of the green building concept. So that is the basic idea behind the whole thing. Mm, okay, now we will go to the next slide. Okay, so these are the different credit categories, lead credit categories, sustainable and non-sustainable credit categories. So here you can see that sustainable sites, water efficiency, whether the water is efficient, energy and atmosphere, materials and resources, indoor environmental quality, innovation in operations and regional priority. So this includes all of these aspects includes, and if the building is able to satisfy the norms which are specified in each category, then it is a lead credit category, and depending on that, the lead certification is given. So this is a very prestigious thing. And now we go to an actual example of a green building. This building actually is a typical example of green building. If you want, you can look up in the internet. There are several examples. In India, the most well-known example is the Bangalore building of Tata Energy Resources Institute. They have taken into consideration all the five elements of nature and how it is balanced within the building to circulate the air, to ventilate the entire building, to give lighting. So you would depend less on electricity from non-conventional, from conventional sources, and you depend on the energy sources from non-conventional sources, really friendly. And for ventilation, you don't ventilation or for air circulation, you don't depend too much on the fossil fuel burning or energy intensive air conditioners, but rather you go for the construction itself. You make it in such a way that there is a natural cooling system which is circulating throughout the building. So you can see in that slide there how the air is flowing. This is typically like in our ancient times they used to build the houses, but this is a bit more scientific. It is done using advanced computer simulation modeling. Then only they are able to build the entire building like this. So this is a typical example of a green building. So here you can see that it is not just a machine or a blade or a fan or a aircraft paneling, but an entire building where human beings have the habitat. That entire building is built in conjunction with the principles laid down by nature. So this entire building can be called as a bio-inspired building. So that is the basic concept behind it. Now I take you to a concept called the industrial ecology concept. Industrial ecology means it is similar to green building concept, but here industrial production, when you produce anything in the industry, industrial production means producing anything in mass quantity with the minimal amount of resources and minimal amount of wastage. And even after the product is produced, how the product is used and how it becomes a waste, and whether that waste is reduced, reused, or recycled. So the entire process I have told you, it is called as the LCA or the life cycle analysis. And if you look at the slide here, you can see the different aspects of production. In industry, you have production, you have consumption, you have waste byproduct, and you have raw materials. So raw materials go into production, the produced goods are consumed, the consumed goods are then converted into waste or a byproduct. So this cycle will continue. The cycle continues within the confines of the natural environment, and this entire process, if it is balanced, or this process is called as the industrial ecological process. And this process has to be as balanced as possible in order to support the natural environment. And when we do this, we are invariably doing a bio-inspired design concept. Now, in this slide, you can see the example, okay, how the production, secondary production, consumption, secondary consumption, all of these things are circulating within each other. Sometimes you might have observed that, for example, in many countries, in the thermal power plant, where the coal is burnt and electricity is produced, you usually have a large water body where the waste water or the waste exchange from the heat exchanger, the water is usually very clean. The water from the heat exchanger is let to cool in cooling lagoons, and the temperature is a little bit high. But this is in a cold country. This particular water can be utilized for growing fish, and then you have sustainable utilization of the water reserves for growing fish, and that fish is again going to produce some products, and you can harvest that fish and you can sell it. So some way of cycling the entire place so that the environment is not damaged, or at least the aspects of the production or the ecology is completely utilized in a cyclic fashion, so that everything is coming in a complete full and final circle. So the circular economy, circular production, circular ecology, sustainability. So these are the core concepts in which every single aspect ends. Nowadays, as engineering students, we should be very much aware of the sustainability development goals, SDG it is called. United Nations has given the SDG. What happened? Oh, I got a gift from Zoom. They have removed the 40-minute timing limit. Where is the slide? Next slide. I want to go to the next slide. Somebody is messing with my slides. Hey, who is hacking my system, man? Last slide. Thank you, slide man. Before that, you're hacking my system. Don't hack my system. You won't find anything interesting here. Now, this this class was for Unit 5, and I have already sent you the slides in WhatsApp. And if you would like to ask any doubts now, you may ask. I leave the session open, or we can ask the doubts in WhatsApp. I think this platform may not allow us to continue the meeting for a much longer period of time. Let us see what happens in chat. And I don't know how to unmute all of you. So now there are 25 participants, and I hope it is being recorded. And Jagadish is also recording something. Okay. So if you have any doubts, you can ask. You can type away in the chat box. I have activated the chat box, so you can ask in the chat box also. What is the time? So the time that you have given me, I think I have finished it much earlier. I finished it half an hour earlier itself in the class. So once again, I want to thank all of you for your patience, especially today. Yeah, aesthetic means, for example, how to tell? If you have if you have like an yellow room and you have a red chair, and you have an yellow room and an yellow chair, and you have a yellow room and a white chair. So which is more pleasing to the eye? Which is better according to the situation? So in a yellow room, at attention. An yellow room, so yeah, fine, yellow. So yellow with yellow is when you want to neutralize, when you want to have symmetry. So it is not just appreciation of beauty, it is more, which is more symmetrical or matching with that particular environment, which is more aesthetically pleasing, which is better for the eye. So usually something which is symmetrical is pleasing to the eye. So that is aesthetic. But all aesthetic things cannot be functional also. Sometimes some functional things will not be aesthetic. You look at a spanner, does the spanner have any beauty? But it is functional. This is like that. Any other doubts you can type. Okay, I'm going to unmute all of you. There's a button here. So all of you are unmuted. Thank you sound from everybody's microphone.
Hello? Sir?
Yeah.
Sir, fully disturbance.
Yeah, holiday, you got a circular now, man. Check. You have your holidays till 14, but
don't know when is
you'll
which
have
days.
to compare, I think. They'll let you know.
10 days, 10 days ಬಿಡಿ ಇಲ್ಲ
As of now, they have extended the holidays to 14th March. You can distribute yourself. Yeah.